Welcome back to the second episode of the Review Buddy program. In this episode, we are going to review another repository work scheduling platform. So here in this application, there is both front end and back end. Back end part is Spring Boot application. So I'm not that great in front end development. So I'm going to stick to reviewing this back end part. So I have already cloned the repository and I'm going to review this backend part. So let's get started. Let's start with a README file. Here there is a brief description about the application, and then at the very high level it shows what is the backend and front-end technologies are using and how to run the application using Docker Compose. Brief contents, I would suggest to add a little bit more details about what kind of a database you are using and what kind of a migration support you are using, things like that. And also I noticed there is systemflow.pdf which contains information about the API endpoints and all that. I would recommend to put that either in a README file in this backend application itself. Imagine if you are raising PR for review by others, and it is much simpler to check out the markdown file and then go through the code changes instead of having it in a PDF. I would recommend to put these details in the README file itself. Okay, next let's start with a pom.xml file. Here the application is using latest Spring Boot framework, and we have usual starters, web validation, data JPA, and using PostgreSQL, and also I think it is using some Hibernate spatial PostGIS thing, and Lombok is there, test. Okay, so some geo support. It is using Flyway migration support, and then here there is a module for PostgreSQL. Usually this version is automatically managed by Spring Boot parent itself, so you don't need to specify this one, so you can remove this. And we have Maven compiler and Lombok. One thing I noticed is the Lombok dependency is added in pom.xml only. I don't see it being used in the actual code, so probably you can just remove if you are not using this. Okay, that's that. And then if you take a look at the Docker file, so basically this is a Spring Boot application, and here we have a multi-stage Docker file. In the first stage, it's a build stage where it is using a Maven base image and then copying the code and building the application here. And then here we are taking the jar file and starting the application using java-jar. Well, this technically works, but the problem with this one is even if you change a single line, it is going to rebuild the whole thing. Basically, you are not leveraging the Docker caching mechanism here. So most of the times we change our application specific code. We hardly change the dependencies. Once the application is stable, we hardly change the dependencies and all that. But if you follow this approach where you simply add the final fat jar itself, you won't leverage the Docker caching mechanism, layer caching mechanism. Instead, if you check out the Docker Spring official documentation itself, there is a section called packaging Spring Boot application, and then there is a container images. Inside that there is a Docker files section. If you go here, you can see once you build the jar file, you can extract the layers. Basically you can run java-jar and extract command that is going to unzip your jar file into various layers. And here you can see you take a base image, probably you use Bellsoft Librica image or whatever the base image you want to use, you can use that, and then you copy layers by layers. For example, here your application dependencies, and then Spring Boot loader components, and then snapshot dependencies, finally your application code itself. So what happens with this one is when you try to build a Docker image, Most of the times these are cached because you won't change the dependencies very frequently, and snapshot probably could change, so that's why it is adding a little bit later. And finally, most of the times you change your application code, so most likely these layers are going to be cached, so your Docker image building process is much faster, and finally you can run your application like this. So this is how I would recommend to go about it. Or even better, you don't actually need to write the Docker file. Spring Boot out of the box provides Packito build pack support, where it will build a Docker image in optimized format. So I would suggest to recommend that for building the Docker image. Okay, next let us go into the source code. Here I see there are no tests. I would recommend to add tests because in the life cycle of your project, it is keep going on and you keep adding more feature, and to make sure that you are not breaking, the only sane way is to write the tests, so that if you mess up anything, it will be caught by using automated test. Otherwise you are going to spend time checking for regression issues and all that. So I would highly recommend to write the tests. Now let us before getting into Java code, let us see what kind of a configuration we have. Let us see, there is application properties. Okay, we gave the name, and then we have data source properties and Flyway and things like that. Here, Spring data source URL, this is the default, and this is the environment variable you are using. But actually you don't need to configure this one, because Spring Boot already supports the mechanism where if you have a property like this, you can dynamically replace with the environment variable. If you capitalize all of this and then replace dots or hyphens with underscore, it will automatically take that value and provide that as this property value. You don't need to explicitly mention this one. If you want to use something like this, then that makes sense. Like I would even recommend this format instead of using Spring specific. Imagine you are building an application and then you package it as a Docker image and give it to somebody else for operations team or something like that. They don't need to know exactly what technology you are using, because a Docker image is a Docker image. You don't need to know what underlying technologies you are using, as long as you clearly specify what properties you need to provide dynamically. So for my database URL, you don't need to specify it is a Spring application. You can simply use something like this, and you can provide the default value, and the operations team, if they want to specify a data source URL, they can do it. They don't need to know whether it is a Spring application or Python application. It doesn't matter. And especially in this case, as this is default, you don't even need to configure something like this. Okay, so that's that. And again, Flyway enabled in Spring, it is default, it is enabled, and also the locations class path DB migration is again it's default, so you don't need to specify that. And validation is fine. This is, I would highly recommend to set it to false. Good. And some Flyway configurations here. And then we have Flyway migration scripts. As I mentioned, the application is using PostGIS, so it created this extension, and then there are scripts where create table if not exists. So usually you don't need to use this if not exist while using Flyway like migration tool, because when you apply this, and usually you will always apply only once, and it should not exist. So you don't need to have this if not exist clauses unless you are again and again running the same migration, which is typically not the case when you are using a Flyway or Liquibase like migration tools. You run it once and internally it keeps track of what kind of tables are already created. So it already know whether you have this table or not. So you don't usually need to use this one, but it doesn't hurt. But in my view, I wouldn't prefer to put this class here. And again, we are creating indexes and all those things. Fine. And yeah, again, same, creating the classes, tables and indexes and things like that. And also here is a funny thing here. We are checking if there is a enum, I think, exist or not. If yes, we are going to add a new enum. Otherwise, it is going to create a existing enum with these values. So as I mentioned, if you are already strictly following that, okay, you know whether you are creating this for the first time or you are extending this, you usually don't need to check for if it exists or not, because you run this, and once, let's say in the v4 version, you create this first migration where you are creating this load status enum. Then if you ever want to add another enum, you only write this other part where you alter this and then add whatever you know, because you are not going to rerun the same thing again. You don't need to worry about, okay, if I run this create again, it's going to throw error, because Flyway won't run the same migration again. So I would say stick with creating once, and Flyway won't run the same migrations again. So you don't need to check for this exist and things like that. So that's about it. And let's start with Java code review. So let's start with the main entry point class. And here we have the main entry point class, and then there is a command line runner being registered, which is going to automatically run once the application is started. And here we are checking, is there any data in some load repository, I mean some maybe loads table, and if there is any data, I think it is already initialized with seed data, and then we are skipping it. Otherwise, we are creating a bunch of load objects and then persisting them into a repository using this repository. Yeah, minor nitpick, instead of using system.out.println, because Spring Boot applications already comes with SLFRJ, I would recommend to use SLFRJ logging instead of using Spring system.out.println. And also, I prefer to leave this main entry point class as it is, and if there are any other bean configurations and all, I would move them to their dedicated classes, configuration classes. In this case, I would maybe create another class, a configuration class where I may name it as data initializer or something like that, and then register this command line runner bean here. And then we have a final class, kind of a utility, I would say. Take some latitude and longitude and create a point class. So basically a utility class. Maybe I would instead put in a utils package or something like that. And then again there is a driver mapper which takes a JPA entity and convert into TTO. Again, either I would put it in service or in a mappers package instead of in the root package itself. So that's that. Now let's start with entities. So let's go with so we have a driver JPA entity. We are using UUID. I mean, if it is a small application, there won't be much large user base, that is fine. But if you think of performance point of view, usually UUIDs are not that performant. People suggest either go with sequence, or recently there is UUID 7 support, so use and also there is another thing called TSID, where some part of that is kind of a timestamp which helps you to sort things, and so you can take a look at that. And we have name, which is a unique column. That is something usually people don't put a unique constraint on name. Maybe you can use kind of a email or something like that, or employee ID or driver ID, things like that. Usually putting a unique constraint on name is something I would not prefer, but I don't know the exact domain in this one. So this is something to take care of. And again, there is a current location and shift, and there is a one-to-many association here. Again, if you are using IntelliJ IDEA, it is already showing this in a kind of a grayed out color, indicating that this is a default parameter. There is no need to explicitly configure that. So you can remove that part. And again, here it shows all the setters and getters. And if you see, use Lombok getter for this thing. That's what I mentioned. Lombok is defined in the pom.xml, but it is not used anywhere. So maybe you can simply remove it. And here you have setters and getters, nothing complicated. Here we have another load and a couple of enums. And again, so here I see some not very cleanly formatted. Imagine somebody is reviewing it on GitHub or somewhere. It doesn't so look good. I would recommend to use some kind of a code formatter, automatic code formatter. For example, here is one of my example sample repository where you can configure this spotless Maven plugin. And you can use there are different types of formatters. You can use Google Java format or Palantir Java format. I prefer to use Palantir Java format, which is again based on the Google Java format. So this Palantir Java format nicely formats Java 8 plus code with the lambdas and all that. So if you configure this one, you can automatically configure, and also you can even verify whether the Java code is properly formatted according to the rules that you defined or not. So it is really nice to use something like that, so that these kind of unformatted code won't get checked into your repository. Okay. So and also there are many-to-one associations with other entities and setters and getters. Again, another entity basic properties mapping, nothing complicated here. And then let's go to DTOs. Again, most of them are simply records, and also some of them are results. That is fine. And also here is one thing I noticed: this lat long is created as a nested record multiple times. I noticed somewhere. Instead, I would recommend to move this into a top level DTO. And one more thing is, usually Java packages are all usually in lowercase. So I would recommend to change this to lowercase DTO. And yeah, also we have. So here, this is what I was referring to. Here there is lat long, which is exactly taking the latitude, longitude. Again, it's a duplicate here. So I would recommend to move this into a top level and don't have the duplicate ones. Okay, so this is login request. This is something interesting. Here we are only taking the username for authentication. But not password or anything like that. I don't know the domain, how it works, but usually you take a username and password. But here in this application, only username is considered. We'll see how this is in controller and talk about it. So these are kind of a basic DTOs, and using records is preferred. It's good. Now let us take a look at the repositories. So here, usually when we are using Spring Data repositories, we don't need to add this annotation, but if you prefer to add it, be consistent. For example, here for one repository there is annotation, for another it doesn't. So use it or don't use it, be consistent, I would say. And then there is a finder method, and also there is one unused method. And here, as I see, there is kind of a complex native query. This is one thing, like if you are using a ORM framework like Hibernate, that doesn't mean that every operation you should force yourself to use uh, JPQL or things like that. If you feel I can express this complex query in native query, you should definitely go for it. In fact, in my experience, in any non-trivial application, most of the times 80 to 90% is using JPA, and 10% or 20% of the cases they reach out to native queries for various reasons, for complex queries or performant reasons and all that. So this is all good. And let us take a look at this. And again, one more. So here, this is one thing I noticed in many classes where the fully qualified name is used instead of using imports. We don't need to do that. It becomes more verbose and all that. So in IntelliJ IDEA, you can do one thing. If you go to settings and inspections, so there is a inspection called unnecessary fully qualified name. By default, the severity is no highlight, but if you make it as a warning and save it, as you can see, now it automatically showed as kind of a warning, and then you get this quick fix where you can simply use import rather than fully qualified name. So that's a nice trick that you can use. And yeah, basically here another technique is used to load the associations entity graph. So you can either use JPQL custom query, and you can use join fetch, or you can use entity graph. Nice. And this one, you don't need a native query. Basically this simply falls into exist by and you can express this as a where class using this one, but either works. But I just saying that you don't need to use a native query. You can express that in Finder pattern. So this is also nice. And again, you don't need this repository annotation, and this is our typical Spring Data JPA repository methods, which is also fine. Next, let us take a look at the services. Again, you can see there is an interface and implementation for each of them. If you know me, you know that I'm not a big fan of this having interfaces, especially if it is only one implementation and hardly there is going to be another implementation. So in that case, I would directly use a class and then implement them instead of having the interfaces and then implementations. If there is a requirement where you need to have multiple implementations in future, in the today's world of powerful IDEs, how hard it is to simply extract an interface from the implementation, and then usually there is an option where you can use the interface reference in all the dependencies. So I would say don't over engineer or overthink, thinking someday you might write another implementation. Start with a class and then implement it. When that day comes where you need to have multiple implementation, it is just a couple of clicks away to refactor that. So let's go here and let's okay, we are implementing that, and then nice, using the final dependencies and injecting them through constructor. Great. And here is one thing I noticed: this a transactional annotation, this is not coming from Spring Framework. Instead it is coming from Jakarta API. So it works. Spring Boot supports this at transactional annotation that is coming from JTA as well, but Spring also provides its own transactional annotation. If you want to take a look at what is the difference, so there is a Beldang article on this, and here you can see Spring transactional annotation provides more option than JTA's a transactional annotation. So there is, you can provide isolation per method, and propagation, it supports more nested transactions as well. So read-only operations. So you have more features when you are using Spring's a transactional annotation. So I would recommend, instead of using this, you can use Spring's transactional annotation. Okay, and we have here we are loading them, find by ID or else throw. So here is one thing I noticed in many of the classes where we are trying to load one entity, and if it is not there, we are throwing this entity not found exception. I see some people following the pattern where they use find and which returns an optional, or if always they are trying to load a mandatory object that you are expecting to exist, if not throwing the exception. So what they are doing, so let's go to this repository, and so here they return a driver not and using this get by ID method, and also make it as a default implementation. So here or else throw whatever a resource not found, or so here you have entity not found or some exception, right? So something like that. So instead of repeating the same logic, loading something using find by and then throwing again, so instead you can simply call get by ID, or you can even make it simply find by ID or throw, which indicates that if you don't find it, it is going to throw an exception. So kind of you can reduce the L or else throw in multiple places and have a dedicated method in the repository itself, which is nothing but simply delegating to this method and then throwing this one. So I would recommend going with this approach. Again, loading the active shift. So here is another thing I noticed from the service layer. I would recommend not to use any web layer components. As you can see, it is coming from web dependency, and also you are specifying what kind of a status code you want to throw. I wouldn't recommend to use anything related to web layer in your service layer components. You should throw same like entity not found exception. You catch it either in controller or global exception handler, and then throw appropriate error or response. Do not use any web layer things in the service layer. Next, so there is most of the business logic, nothing complex here. And again, instead of throwing this JDK exceptions, though maybe it is semantically correct, illegal state exception, but I would still prefer to create a custom exception that clearly indicates what exactly is wrong, because this can be occurred for n number of reasons. Maybe you invoke some API, JDK API internally, it is throwing this one. So to clearly distinguish between your application exceptions versus the Java exceptions, I would always recommend to create a business specific exception. And again, invoking some private method here. And here there is again same pattern using find by and throwing. As I already mentioned, you can create a default method in the interface itself. Fine. Here one thing I noticed, the methods are a bit longer, and we are doing multiple things here, maybe checking the data, validating it, and then based on the data context, you are performing different types of operations. I would say break it down into multiple private methods. So basically, you in the service layer, you at the top level, you should be able to understand, okay, when we say complete next step, what is happening. Looking at the method names, you should be able to at the high level understand what exactly you are doing in this one. But here we are mixing the business logic with the low level implementations, how you are loading the data and then comparing and then creating beans and all that. So I would say break it down into multiple private methods, and then looking at the method calls, you should be able to high level understand, okay, so first we are loading this and then we are checking this. If this is the situation, we are doing this different operation. So I mean, splitting the business operation versus low level implementations. Okay. And okay, so this is usual code. Again, as I mentioned, do not use HTTP related exceptions in the service layer. Okay, so long methods. So this all looks okay. And also sometimes, for example, here we are determining whether a load is already released or something like that. And here most of the data is coming from the load, and the only external part is a driver ID. In this case, maybe a better option would be to create a method with a meaningful name in the load class itself, and maybe you can simply pass the driver ID and ask, is it already released for this driver? And so you don't need to repeat this logic. This could belong to the load domain object. Nice. So let's move on to other classes. And here again we have our driver service implementation. And yeah, here is again, as I mentioned, in the login case, the funny thing is we are taking only username. Again, I don't know the business context why it works just by taking the username, and if it exists, we are using it. Otherwise, we are simply creating a new one and then returning the response. We are not checking the password or anything like that. That is something to check. Otherwise, it is simply loading the data and then mapping it to a DTO, which is usual. Again, here, because it is using Jakarta Transaction API, you don't need to use it. You can use Spring's transactional annotation, and if you put required, if it is already existed, currently, if there is any ongoing transaction, it will also run in the same. Otherwise, you can also use propagation level as supports. So if there is a transaction, this method is going to run in the same transaction. If it doesn't start. So it just supports if there is one going on. So this support is also available in Spring's transaction as well. Next, let us take a look at the load service. So again, nothing super complex. Here is one thing I noticed. Here there is a private method that takes latitude and longitude, and then using this. Okay, so here it is defined this as a dependency and simply creating a new object. It is not being injected as a Spring Bean. We are simply creating a new instance here, and then we are using that to create a point from the given latitude and longitude. And if you take a look at this JTO geo, it is kind of doing the same thing. It is creating this geometry factory and then taking the longitude, latitude, and returning the point. So basically we have a duplicate logic, where I would recommend, if you want to create this and then maybe expose this as a Spring Bean and use this method instead of duplicating this logic. And also, not found exception, you can create this as a top level class in a different package or somewhere, because I guess it is being used in different places. Okay, so next, shift service, and again here, okay, we are loading the driver information, and then we are checking is there any shift available for the driver, and then we are checking driver is on shift. So here is an interesting thing. Here we have already loaded the driver from the database. We already have the information, and then we are making another check and using the OR operation. So I would say is flip this to make this as the first check here, and then do this, because if this is this data is already available, so you can, it's a simple method call, it doesn't talk to database, things like that. And if it itself is true, you don't need to perform this database operation. Otherwise, if you have the in the other way around, either this is true or false, you are going to make this first database call, which is kind of unnecessary. So flipping this, if this is true, you can avoid making this database call itself. So that's it, and the rest of the things looks fine, typical business logic. So what I noticed in the services, use the Spring's transactional annotation and probably create find by ID or throw methods in the repositories instead of calling this everywhere, or else throw entity exception and things like that. Okay, so that's about the services. And finally, let us take a look at the controllers. And here we have a controller and we injected the dependency. We have a API endpoint. So here, this is something I don't recommend, because when I take a look at this one, I would like to know what kind of a response we are returning. By placing question mark, maybe you have the luxury to return whatever you want, but I would prefer to think hard and decide what kind of exception you want to throw, what kind of response you want to return. So in this case, maybe this is the expected one. You should definitely use this instead of question mark and do that. So again, here we are catching the response status exception, and then we are constructing a map returning the response. Again, instead of returning a ad hoc map where you don't know what is going to be in that map, I recommend creating a dedicated error response object and then return it with whatever the data you want to return. Even better, there is a problem details API, which kind of a return a standard response format. I would recommend to use that instead of creating these ad hoc maps and populating with whatever the data. Instead, follow this problem details API. And one more thing is, we are catching this entity not found exception and illegal state exception in multiple methods, and we are not doing anything different because all of them are doing the same thing. In case of not found exception, we are returning the HTTP status 404 with the error message. So I would say, instead of duplicating this exception handling all over the place, you can create a global exception handler and use the at controller or at rest controller advice and centralize the exception handling logic. So that's what I would recommend. Most of the controllers have the same thing. And one more interesting thing is, so here we have some logic here, and then a exception handler is created in this method, and what happens is this is going to be effective only when entity not found exception is thrown from any of these methods only. If the same exception is thrown from let's say assignment controller, this is not going to handle that exception. This is kind of a local one. So that's why I would say create a global exception handler. For example, let's create global exception handler and add rest controller advice and move that method there. Okay, so I think you can move this as well. So this way, it doesn't matter in which controller this kind of exception is thrown, it is going to catch all of them and then return the response accordingly. So that's what I would recommend. And load controller, again here we are loading this data. Most likely while loading you may not get any error, that is okay. But here what happens if you get some UUID and there is no load exists for that UID, it is going to throw exception, and because you haven't implemented any special logic to return 404 or anything like that, you probably get a 500 exception or something like that. So I would recommend to think through. Maybe you can throw, if you don't find load with the given ID, you might throw resource not found, and then you catch that exception here and return 404, something like that. Same case for this one. If you don't find, you throw an exception, and then you can handle that in global exception handler. Again, same thing here. Do not return ad hoc map as the response. You always create a record and then populate the data, because people are going to maintain the application for a long time, and if you keep it like that, people, whenever they want some ad hoc data, they keep adding it, and looking at this, you don't know what kind of a data you are going to return. So always creating a record or something and then returning it, they can take a look at that record and see, okay, what kind of a response you may get. So again, no need to handle all the exceptions in the same way. Instead, throw them and then handle them in the global exception handler. So I think these are all the things I found in this backend implementation. I hope some of them are useful, and maybe you can apply these suggestions I mentioned and improve this one. So thank you, and I hope this is helpful. Bye bye.